All right, we are back. I was kind of going through those problems and I decided to pause for a second, open up Desmos, type in all these functions so that way you could visually see what's happening with these. For me to sit here and draw each of these on a piece of paper would not only be super boring, but would take up a ton of time. And I don't want to like lose people with the information that you need to know. So just like I've said before, we need to embrace this idea of electronics and using calculators, especially through Desmos. So I'm going to do one of these by hand, but then I'm going to go back and just show you exactly what all these look like and all these transformations that are happening here. So if I had, let's pick a problem here. Let's pick maybe number 20, and we'll graph this one. So this is going to move left one and up one. So I'm going to draw my x-axis, draw my y-axis. Okay. And we're going to graph the parent function, and then we'll graph the transformed function. So that way you could see how this is done by hand. All right. So our parent function, so parent is just y equals x squared, or f of x equals x squared. It doesn't matter. So basically what I'm doing to create these points is I'm just plugging in random x values, and then I'm going to square it to see where I go. So for example, if x is 0, well, 0 squared is just 0. So that's going to be one of my points for my parent function. If x is 1, 1 squared is 1. So I know I'll go over 1, up 1. So there's another point. What about to the left? If x is negative 2, well, negative 2 squared is just 4. So I'm going to go left 2 and up 4. 1, 2, 3, 4. So you just keep going, right? Same thing with negative 1 squared. That's just 1. So left 1, up 1. Same thing with positive 2 squared. That's just 4. So right 2, up 4. And then you can keep plotting these points to see what that should look like. So if I go over 3, I should go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see if I can do 4. If I go over 4, I'm going to go up 16. 4 squared is 16. So that's 9, 10, 11, 12, 13, 14, 15, 16. And I think if I did 5 squared is 25, I'd be off the page. So we'll call this as good as we're going to get. So remember, we talked about that axis of symmetry. That's that line x equals 0. All of the points that are laying on the right are going to mirror the same points on the left. So notice that this point on the right is only 1 unit away from the axis of symmetry. So then the point on the left is going to be 1 unit away. Same thing with this point here, 2, 4. It's 2 units away from the axis of symmetry, right? So the left point is going to be 2 units away. So 3, 9, that point is 3 units away. So this one is going to be 3 units away. Just kind of a little bit of a shortcut. This point, 4, 16, that's 4 units away from that axis of symmetry. So this point will be 4 units away. 1, 2, 3, 4. So I'm going to do my best to sketch this off. It's going to look rough, but you'll get the point. So something like that. So that is my best drawing for drawing my parent function f of x equals x squared. So let's draw, again, we're doing number 20. So let's go ahead and draw this function that's on there. So there's 4 transformations. It's going to reflect, it's going to stretch by a factor of 2, it's going to shift left 1, and it's going to shift up 1. So the first thing I'm going to start with is the vertex. So I'm going to start from that vertex, and I'm going to go left 1, up 1. So there's my new vertex. I know it's reflected, So I know it's going to be opening down, right? So I know right now it's going to open up in this direction. It's going to be a frowny face. But the only way I'm going to find the points is if I apply that stretch of 2. So here we go. So our first point on our parent function was over 1, up 1, right? So we only went up 1 unit. Well, same thing should happen here. If I go over 1, it doesn't matter if I go left or right, because remember, there's that axis of symmetry. It's going to match. If I go right 1, instead of going up 1, I'm going to go down 1, right? Because the negative. But instead of going down 1, this is being stretched by a factor of 2. So I have to go down twice that amount. Instead of going over 2 down 4, I'm going to go over 2 down 8, because that stretch by a factor of 2 is telling me to take all my down and I'm going to multiply it by 2. So over 2 down 8. 1, 2, 3, 4, 5, 6, 7, 8, right? You'll see that I'm off the page. Same thing with the left. If I go left 1, I should go down twice that amount. So it's going to look something like this, right? It's going to be stretched out. The vertex moved, left 1, up 1. It's reflected. So all 4 of those transformations are there. Of course, if I would have made this origin maybe in the middle, that would have been a better idea. Then you could see more of those extra points. But let me show you how we can look at this using Desmos. So there's my parent function, and I'm going to look at all those problems that we ended with, 16 through 21. So here's number 16 on that page. You can see there's no a value, h is 1, and k is 3. So I wanted to take that vertex from the red function, and I want to move it right 1 and up 3. Remember, it's always going in the opposite direction. Same thing with number 17. This is saying x plus 1, so I know in the opposite direction that would be left 1. So I'm going to move this vertex left 1 unit and down 3. So from my red function, the vertex moved left 1 and down 3. Number 18. This is that one that kind of looks weird, but technically it's still the same thing as 2 parentheses x minus 0 squared plus 0. Notice that it didn't move. My vertex didn't move left or right. It's still the same exact vertex, but here's a great example of how we're going to be able to see that a value, that stretch of a factor of 2. So take a look. With my red function, if I go right 1, 1 squared is 1. Bam. But now, if I go right 1, take a look at my transformed function. I'm going up 2. So I'm going up twice that amount. With my parent function, normally I'd go right 2 and up 4, because 2 squared is 4. Let's see if we can get this down here. Now, with my transformed function, I know my a value is 2, so I'm going to multiply all my ups and downs by 2. So instead of going over 2 up 4, I'm going over 2 up 8, because I'm multiplying that height by 2. All right, and then this is number 19. So a few transformations. You got the negative, so you can see that black function reflected. It turned into a frowny face. The vertex moved from x minus 1, so that's telling me to go in the opposite direction. So that's plus 1, which means right 1. So from the red function, my vertex moved right 1, and then up 7. Bam. So right 1, up 7, then flip it upside down. This is 20. This is the one that we just did on paper. This is kind of rough to see. I don't know if I can change colors, but I'm not sure how to do that. So this red one that's facing up is my parent function that's at the very top. This one that's facing down is the transformed function. This one right here, that's number 20. So you can see, if I kind of zoom out a little bit, you'll be able to see that it's stretched out a little bit. You can kind of tell that the parabola was a little bit wider up at the top compared to the bottom. You can see that this bottom one kind of got a little bit narrower, stretched out. So it was reflected, which is the negative. It got stretched by a factor of 2. So instead of going over 2 up 4, it went over 2 down 8, right? You're going down, up or down twice that normal amount. Then it went left 1 and up 1. So you can see that vertex from the original function, from my parent function, moved left 1 and up 1. So that's all basically 4 transformations. The book is lumping A as -2, but technically that's 2 different things, a reflection and a stretch or compress. And then number 21, so this was 3 different ones. My A value is 1/2, so you can see that that's a value that's between 0 and 1. So you can see how that flattened it out a little bit, right? See how that kind of widened it a little bit? Look at my parent function, the red function. That blue function looks like it was widened. It kind of gotten flattened a little bit. So, all right. So that is 16 through 21. Let's take a look at 22. Identify the vertex axis of symmetry, maximum or minimum, domain and range of each function. So we're not really comparing this to the parent function, so I'll go ahead and turn off that parent function. But number 22 is this one right here. So I'm just looking at my paper, y equals 2 times x minus 2 squared plus 5. That's number 22. And that's what I have listed here. So that is my green function right there. So they want us to find a bunch of different pieces of this. Identify the vertex. Well, the vertex is that point where your function bounces. So in this case, it's a positive function. So it comes down and it bounces right there and then goes back up. In Desmos, if you click on that, it'll actually give you that point. You got to click on the vertex. So my vertex is 2, 5, h is 2, k is 5. Axis of symmetry. If I could create a line, which I can, let me go ahead and do this. I'm going to say x equals 2. X equals 2 is that line of symmetry. Notice if I look at this parabola, see how on this line that goes through your vertex, the axis of symmetry will always go through your vertex. Notice the distance in the left and the right-hand side. It's always the same. If I took all the junk on the right-hand side and I folded it across that line of symmetry, it would match up with all the stuff on the left-hand side. So the important thing with the axis of symmetry is x doesn't change. I'm still going over 1, over 2, over 3. It doesn't matter, right? The thing that the importance of the axis of symmetry is that the distance between my x values to the axis of symmetry is the same. So let's look at this right here. So that's 3. So notice this point right here, right? I went over 1. Notice the point on the left from that axis of symmetry goes over 1. This point right here, right? From the axis of symmetry, I'm going over 2. So same thing with the left, I'll go over 2. So that distance between those points and that axis of symmetry has to match. So with number 22, that axis of symmetry is x equals 2. That's that line, that blue line that's there that I created. Maximum or minimum. So a function is going to have one or the other with quadratics. So this actually has a minimum because if you look, you'll trace this function from the left and it comes down, 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 and it stops going down. It never goes below that point right there because then it turns around and bounces and comes back up. So a positive parabola will always have a minimum. A negative parabola will always have a maximum. Let me turn this on real quick. Look at this parabola down here. This is -2 for my a value. Notice this parabola from the left goes up, 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 up. It stops going up and bounces and goes back down. So that's got a maximum. So when a is negative, you're going to have a maximum. When a is positive, you're going to have a minimum. So identify the maximum or minimum. Turn that back on. There's the problem we're on. Again, we're on number 22. The minimum is going to be at y equals 5. You could also just give the actual value, the point, 2 comma 5. But typically y equals 5 is going to be the minimum. Like you'd reference it like that. And then domain and range. So this is old news. We know parabolas never stop going up and left, up and right. So this never stops going left and right. So that means my domain would be from negative infinity to positive infinity using parentheses. My range is a little bit different. Since this function has a minimum, it never drops below 5. My range would be all my y values that are greater than or equal to 5. You could also reference it as in an interval notation. So it would be from 5 to infinity. So the lowest it ever reaches is 5, but it never stops going up. So it would actually go to infinity. So from 5 to infinity. And then again, that would be brackets at 5, parentheses at infinity. I should emphasize that. Brackets because you're actually touching the vertex, parentheses because you can never actually reach infinity. So the next 3 should go a little bit quicker. 23. There's 23. Identify all that information. Center us here. Identify the vertex. Again, in Desmos, you can just click on it right there. So the vertex is at 1, 2. Axis of symmetry. Looks like that's where the vertex is at. My x value is x equals 1. So that would be my axis of symmetry, x equals 1. It's always going to be the x value of your vertex. Maximum or minimum. Well, since this is a negative parabola, it's going to have a maximum. It never goes above y equals 2. And then domain and range. So domain, all parabolas, unless there's a restriction on it, always negative infinity to positive infinity, using parentheses because you can never actually reach those values. So domain is negative to positive infinity. But the range, that's where it's restricted, right? This parabola only goes up and then stops going up at y equals 2. So your range would be something like y is less than or equal to 2, or you can use interval notation and do from negative infinity using a parenthesis, comma, 2 with a bracket. So parentheses, negative infinity, comma, 2 with a bracket. And then number 24, the vertex. Again, you could just look at the function and tell what the vertex is. It's always going to be the opposite of h, comma, k. So the opposite of negative 1 is positive 1, and then k is 2. So you know your vertex is going to be at 1, comma, 2. I get the right one clicked on here. Oops, I don't. There we go. The vertex is at 1, comma, 2. You can click on that to verify it, or you can just look at the function and it tells you that. Axis of symmetry, again, this is always going to be the x value of your vertex. So the axis of symmetry is x equals 1. Maximum or minimum, this has a maximum. It never goes above y equals 2. So it's got a maximum of y equals 2. And then domain and range, this is just a parabola. So domain is from parentheses, negative infinity, comma, positive infinity, parentheses. And then range is where it's going to be restricted. This function lives below y equals 2. So there's nothing above that line, y equals 2. Let me go ahead and just emphasize that here. Y equals 2. You can see that line right there. That function does not live above it. So what you want to do is you want to emphasize all the stuff below it. So again, you could say y is less than or equal to 2, or you can use interval notation and just say negative infinity. That uses a parenthesis, comma, 2 with a bracket. And then the last one, number 20. I don't know if I just did the same one again. I think I just talked about the same one twice. Let me talk about this one. So this one is number 24. So this has two transformations, the negative, which means it reflected, and then my h value is -4. So you could see that this vertex moved left 4, and it's reflected, it's upside down. So again, I think my vertex is going to be at -4, 0, because there's nothing on the outside, there's no k value there. So you could click on that parabola on the vertex and verify that. Axis of symmetry, the x value is -4, so the axis of symmetry would be x equals -4. Maximum or minimum, this has a maximum of 0, so it doesn't live above the line y equals 0. So you could say y is less than or equal to 0, or negative. Sorry, I think I'm mixing those up. Maximum or minimum, we have a maximum of 0. This never goes above y equals 0. So y equals 0 would be my maximum. Now domain, this is a parabola, so it goes left and right forever, never stops doing that. So domain is from parentheses, -infinity, infinity, parentheses. And then range, this thing lives below the line y equals 0. So that's the tallest it ever gets. So my range would be parentheses, -infinity, 0, close bracket. All right, and then our last problem in that section, number 25, you could see my vertex is going to be at -2, -1. You could also click here to verify that. Axis of symmetry is always that x value, so x equals -2. It's always the x value of your vertex. This thing has a minimum because it's a positive parabola, so the lowest it ever gets is right here at -2, -1. Or you could say y equals -1. Either way, that references the lowest that parabola will ever reach. Domain, all real numbers, parentheses, -infinity, +infinity, parentheses, however you want to emphasize that. Basically, any number works on domain, but the range is where it's restricted. This function only goes down to y equals -1. It only lives above that line. So my range would be bracket -1, infinity, parentheses. All right, and I think we are done with Desmos. So let's go back and knock out these last few problems. All right. Write the equation of each parabola in vertex form. So this is similar to an example that we saw back in the lesson, example 4. Example 3. They're giving you basically 2 points, and you've got to create that function off of those 2 points. So with our first question, number 26, the 2 points are 1, 2 and 2, -5. Remember, this generic function that we're plugging this into is y equals a times x minus h squared plus k. So in this problem, they're giving us, 4 of those missing pieces of information. If it's our vertex, that's h and k. If it's just a point, that's x and y. So all I have to do is plug in that information. So I know y, that's -5. I don't know a, that's the whole reason we're doing this, is to figure out what a is. X is going to be 2. H is going to be 1. And then k is going to be 2. So now I've just got an algebra problem. I got to solve for a. So if we go through this, you always do what's inside parentheses first. So 2 minus 1 is 1. Then I do exponents next. So 1 squared is 1. I could simplify this a little bit. Instead of a times 1, that's the same thing as a. And now I can just solve for a. Subtract 2 from both sides. So I get a equals -7. So they want the equation in both, or write the equation in each parabola in vertex form. So we don't have to write it in standard form. We don't have to go through those steps like we did back in that example. So I think we're ready to plug this information in. We know y, we know x, we know h, we know k, and now after we did that math, now we know a. So it's going to be y equals, or you could use f of x. A is -7. H is 1. So remember, I always want to say the opposite, right? I wouldn't want to write x plus 1 because that would actually be a piece of false information. And then k is 2. So here is our vertex form of that problem. Number 27. Again, we're just going to plug in those pieces of information. They're telling you the y-intercept. That's still a point. If it's a y-intercept, that means x is 0. So I can also write that point as 0, 2. And now I'm just going to do the same thing we did in number 26. So y equals, y is 2. A, that's what we're trying to find. X minus h, so x is 0. H is 3. Plus k. K is 6. So 0 minus 3 is -3. -3 squared is 9. And then if I solve this problem, I'm going to go ahead and subtract 6 from both sides. I'm going to rewrite a times 9 as 9a. Divide both sides by 9. And I get -4/9 equals a. Let me just double check and make sure I didn't screw something up there, because I don't know if you're supposed to have a fraction or not. So h is 3, k is 6, y-intercept x is 0, 2, -3, so that's 9, minus 6, divided by, yep, so a is just -4/9. So if we plug this into a function, y equals a times x minus h, in this case h is 3, and then k is 6. (28). Just another point, or another set of points. So same information. Y, again, vertex, that's h and k. And then my point, that's x and y. So y equals a, that's what we're looking for, x minus h squared plus k. So if you do the math, x, or 1 minus 0 is still 1. 1 squared is 1. If I solve for a, I'll subtract 5 from both sides, and I get a equals -7. So at this point, I'll plug it all back in. I'll also use f of x just to emphasize it doesn't matter if you use y or f of x. A, parentheses, x minus h squared plus k. Typically, you won't see this written like that. They're not going to leave it as x minus 0 because you could simplify that. X minus 0 is just x. So what they'll actually write in probably the solution manual is something like that. There's no reason to have it x minus 0, so you might as well just simplify that. Uh, 29, write the equation of the function represented by the parabola in vertex form and in standard form. So here's where they want you to do both. So in vertex form, it looks like the vertex is at -1, -6. They're also telling you that right there. So I know vertex is at -1, -6. So let's just kind of start plugging in some information. We have y equals, We don't know what A is. We'll look at that here in just a second. It's facing up, so I know that it's positive, but it could be stretched or compressed. But let's go ahead and plug everything else in. X minus h, so h is -1, so -1, I'll write it like this, x minus -1 squared, plus k. So whatever k is, tack that on at the end. If you wanted to write plus -6, you could. I'll just simplify it, write -6. Let's take a look at the stretch or compress and see if there is one. Typically on a parent graph, on a parabola, you should be able to go over 1 and up 1. You can also go over 2 and up 4, right? Let's see if this kind of matches. From the vertex, if I go over 1 and up 1, I'm not hitting my parabola. It looks like I have to go over 1 and up 2. So that's telling me my A value is 2. I'm going up twice the normal amount. Again, normally I'd go over 2 up 4, right? Because 2 squared is 4. Let's see how far we go up. Over 2, up 1, 2, 3, 4, 5, 6, 7, 8. So I think I confirmed it. We're going up twice the normal amount, so A must be 2. Let's simplify this a little bit. These double negatives, those don't need to be there. So y equals 2, x plus 1 squared minus 6. So there is the vertex form. They also want it in standard form, so you're going to have to multiply this out. X plus 1 squared is x squared plus 2x plus 1. I'm going to distribute that 2 to that parabola, to that quadratic right there. So it's y equals 2x squared plus 4x plus 2. And then finally, subtract that 6. Y equals 2x squared plus 4x minus 4. So there's the standard form of that function. All right, 2 more problems. Write the equation g of x in vertex form of a quadratic function for the transformations given for f of x equals x squared. So let g of x be the function whose graph is a translation, so it's basically shifting, it's moving, 4 units left and 1 unit up from the parent function. So basically just a quick sketch. If this is the parent function, that parabola is going to move 4 left and 1 up. So 1, 2, 3, 4, and 1 up. So there with that, that's the new parabola right there. So they're wanting to know, they're just wanting the function. They don't want you to sketch it though. So if you want it to go 4 left and 1 up, you've got that generic function, y equals a x minus h squared x minus h squared plus k. All you're doing is plugging in the information they want you to do. So they want you to show that it's moving left 4 and up 1. So that's just going to affect your h and your k value. So it's going to be y equals, you don't have an a, they're not telling you to stretch or compress it or reflect it. So we'll just skip a. If you want to tell somebody to move that thing left 4, right, you're basically plugging in a -4. So you'd have something like this, x minus -4. Well, if you simplify that, whenever you subtract a negative, those double negatives just turn into x plus 4. So if you want to tell somebody to move it left 4, you're going to have to write x plus 4. And if you want to tell somebody to move it up 1, you'll have to write plus 1. And then 31. So the transform function whose graph is a reflection. So that's one of the transformations they want us to show in the x-axis and translated 3 units right of the graph. So you want you to reflect it and translate it 3 units right. So again, y equals ax minus h squared plus k. If they want you to reflect it, that means that a is negative. And if they want you to shift it right 3 units, that's the same thing as saying plus 3. So again, visually, this is what you got here. You're just putting a 3 in for h, but it's x minus 3. They're not telling you to move up, so you don't need a plus 0 there. You would just leave it just like that.